Good day, ladies and gentlemen. Today, what we're going to do, we're going to look at the key to Unit 7, Lesson 1. Key. The quiz tomorrow is going to look like this key. So let's jump into the problem. I want to make this a fairly short video, as short as I can. Make sure you can always pause the video to write the answers down. So here I have triangle ABC where measure of angle B is 90 degrees. So I have a 90-degree angle right here, and this is a right triangle. And AB is equal to BC. Bam. They tell me AB is 8, therefore BC is 8. And they tell me this in this statement right here. So 8 is equal to 8. I get this guy right here. Well, what kind of right triangle is this? If the legs are congruent, we're going to say that this, we're not going to say it, it actually is a 45, 45, 90. And if I recall from last week, the property, in the week before, properties of 45, 45, 90 is that the hypotenuse is square root of 2 times the leg. So I can jump right here and say, oh, this is 8 square root of 2. If you want to use the Pythagorean theorem and to find that, you certainly can. I'm not going to do it in this video. It's going to be enough to know that the length of this hypotenuse is 8 square root of 2. And I know that, yes, the angles are both 45 degrees. So that was easy enough as well. Okay? And now I'm just going to use the geometric definition of the trigonometric ratios. What is the sine of A? The sine of A is going to be what? Well, here's two simplified radicals. The sine of A is going to be 8 over 8 square root of 2, which is going to be 1 over square root of 2. I'm going to multiply that by square root of 2 over 2, and this is going to be 2 square root of 2 over 2. That's what the sine of A is. Well, that's going to be the sine of C as well. Well, look at this. What's the cosine of A? The cosine of A is still 8 over 8 square root of 2, and so that's going to be square root of 2 over 2 as well. So all four of these, since the angles are congruent, are going to be the same. Square root of 2 over 2, square root of 2 over 2. So, alrighty. So, and then what's the tangent of A? The tangent of A is opposite over adjacent. 8 over 8 is 1. And so, therefore, the tangent of A is tangent of C. And then what's the cotangent? Cotangent is 1 over the tangent. So what is 1 divided by 1 is 1. So you got this guy. And then the other thing we need to know is 1 over the cosine. Secant A is 1 over cosine of A. So secant of A, let me write this here. Secant of A is equal to 1 over cosine of A. Well, we knew that cosine of A was square root of 2 over 2, so I get 1 over square root of 2 over 2. And here I have simplified that. 1 over square root of 2 over 2 is 2 over square root of 2. Simplify that, multiply by square root of 2 over 2, and you get square root of 2. So therefore, the secant of A is square root of 2. Secant of C is the same. Cosecant is 1 over sine, which is the same. So it's really nice. These values are nice if you have a 45, 45, 90. All right? So you can write those answers down, think about how I got it. It's a simple matter of geometric definitions of the trig ratios and then simplifying some radicals. We definitely want to use simplified square roots. Okay? This next problem right here, I have a circle with center 0 at O. This point here, 1, 0. So, and I know BOA right here is 30 degrees. And we talked about this in yesterday's video, but you didn't even need yesterday's activity to get this. You would have been able to figure this out. Because what do we have here? Here we have a 30, 60, 90 right triangle. They tell me that this is 30. I know I'm in quadrant 2. I know the x's are negative, the y's are positive. This is things that we have brought with us from the 6th grade and 7th grade. I know this hypotenuse is 1. And therefore, I can easily go back in my notes and I can look at a 30, 60, 90 where the hypotenuse is 1. And I realize that the opposite side is going to be 1/2. And then the short side is going to be 1/2. And the long side is going to be square root of 3 over 2. Well, now I can figure out what these coordinates are then. Because this side right here, and I'll do this in blue, it's going to be the x value. So the x value is square root of 3 over 2, but We're in quadrant 2, so it's going to be negative square root of 2 over 2. And here this y value is 1/2. We are in quadrant 2. It's going to be positive. And in like manner, we're going to get the coordinates of point D. And the coordinates of point D, I'm going to look at this right triangle right here. And they tell me EOD. EOD is 60. So what do I have? I have another 30, 60, 90. Okay, where the hypotenuse is 1. And what do I know? Short leg is 1/2. This distance here is square root of 3 over 2. But since I'm in quadrant 4, the y's will be negative. All right? So easy enough. You can take a picture of that. That's the key for that. There's going to be a question like this on the quiz tomorrow. So let's jump to the next page. The next problem is number 3 right here. I have another right triangle where ST is 7 and RS is 10. I'm going to use the Pythagorean theorem this time because this is not a special right triangle. This is just a right triangle. So I'm going to have to use the Pythagorean theorem as I did to find the length of RT, and RT is going to be the square root of 149. The square root of 149 does not simplify, so it is already a simplified square root. Found RT. The sine of t then, the sine of t is going to be the opposite. I got this mixed up. So we're going to, the best way to do this, the sine of t, I was doing the sine of r, is going to be 10 over square root of 149. So I'm going to fix this key right here. It's going to be an easy fix right here. So the sine of t is going to be 10 over square root of 149. Simplify that, and you're going to get 10 square root of 149 over 149. The cosine of t is going to be adjacent, and that simplifies to 7 square root of 149 over 149. And then the tangent of t is not 7/10, folks. No, sir. A little error on that rascal, didn't I? The tangent is the opposite over hypotenuse, so that this tangent of t is going to be 10/7. So I'm glad I got that. Okay, so there's the answer to number 3. And then I've got these writing problems. And here I have a consider right triangle with right angle at O. I got this guy right here. Okay. And if the length of CA right here is close to the length of OC, then the sine of angle A is going to be close to what number, but not greater than what number? Well, the sine of A is going to be what? The sine of A is going to be the opposite, which is OC, over the hypotenuse, which is CA. Well, what do you know about that? You know that sine of A is close to 1. Why is it close to 1? Because CA is close to OC. These are close to the same length. Okay, so this rascal here is going to be close to 1. Okay, it's going to be close to 1, but it's never going to be greater than 1, because what do you know? You know that OC will always be less than OA. This length right here, this leg here, has to always be less than the hypotenuse. That's just a property of triangles. That's a triangle property. Certainly a property of, we can say a property of right triangles. So this guy is always going to be less than 1. It's never going to be greater than 1. Couldn't be greater than 1. If it's greater than 1, then we're not in a right triangle. And geometric trig ratios only work in this right triangle. So and then we'll go to the next writing thing. If the length of OA is really close to 0, as it looks like it is, if this dude right here is close to 0, the measure of angle A is going to be really close to what? I think it's obvious that it's going to be close to 90 degrees. It's not going to be 90. It couldn't be 90 if it was 90, because this is 90. If it was 90, then it would just be a single line. So it's going to be close to 90, and that's certainly a property of right triangles as well. So not a lot of discussion here. A lot of good discussion here. Not a lot of discussion needed here. But here's a really good question. If OA is indeed really close to 0, then the tangent of A, what's the tangent of A? The opposite, which is OC over OA. Ooh. And OA, what do we know? OA is really close to 0. If OA is close to 0, and OC is not, OC is way bigger than 0. OC is greater than 0, way greater than 0, but OA is going to be close to 0. So this guy right here, OC over A, is going to be close to exploding. Do you remember on rational functions, when I have a number over 0, what happens to the function? It explodes. And that's the same thing that's going to happen here. This is going to explode, and it's going to explode to infinity. Since a number over 0 is an explosion, there's a vertical asymptote. So this number right here is going to be close to infinity. So that's a 12, 13-minute video over the answers to lesson 2. There will be some, let me zoom out here to one page, the entire page here. Maybe help you can take a picture of that. There's going to be a couple of problems where you have to think on your noggin tomorrow. There's certainly going to be a problem like this on the quiz. And if I go back, you can take a picture. I'm going back to this page right here. There's going to be a problem similar to this. Might be a 30, 60, 90. And then some problems where you have to find the coordinates on a circle with unit 1, a radii 1. Alrighty, so I will see you later. Alligator.